Okay, good morning, everybody. Welcome to the Local Agency Traffic Safety Academy. My name's Anthony Chamont. I'll do a quick introduction of some of the materials. Everyone that is here today received the email that is up on my screen with the invitation. You followed the link to get here. A couple of important things on there. My email address, should you have any technical questions or issues downloading the webinar that will be hosted on the Tampa Bay Traffic Safety Academy site. Dennis Falloon's email. He is our Safety Academy coordinator. You'll hear from him in a moment. And the email to the Tampa Bay Traffic Safety Local Agency Traffic Safety Academy site. That takes you to this web page that I have here. It lets you know the upcoming topics that are coming for, throughout the rest of the year. As new topics are scheduled, they are added to this list. It shows you the completed webinars for 2018. As well as a registration link. This is, the link that you sent to someone that is interested in joining the webinars that is not here today. All of the past presentations going back to 2013 are here, as well as the ones for this year. This is the location where today's presentation will be, and the recording will be on the right side. Today's handout is already there, the systemic approach to safety. We have 2 presenters today, and you will also find this PowerPoint in your handout pod in your GoToWebinar window. In your GoToWebinar window, as well as in the resources at the bottom, is the PDH request form for professional engineers seeking development hours for this webinar. With that, I will hand it over to Dennis for his introduction.
Good morning. This is Dennis Falloon, the FDOT Local Agency Traffic Safety Academy Coordinator Consultant, and I want to welcome you to the 8th webinar for the 2018 FDOT Local Agency Traffic Safety Academy. Today's safety webinar topic is Systemic Approach to Safety by Chad Pope, who's a professional engineer, project manager with Jacobs in Tampa, Florida. And Chad has been in the industry for over 16 years, and his safety work includes systemic analysis, safety studies, highway safety manual analysis, safety training to local agencies, and safety research at a national level. Chad also holds a BS in civil engineering from the University of Missouri. And also our second presenter, Robert Paquin, is a safety analyst with Jacobs in Tampa, Florida. And he's been in the industry for 4 years, and he's worked in the traffic safety realm and has performed systemic analysis for multiple state and local agencies. And he holds a BS in civil engineering from the University of Minnesota and a BS in physics from the University of Wisconsin-Eau Claire. And with that, I want to kind of give you a quick introduction to the Academy before they begin their presentation. So as I mentioned earlier, this is the FDOT Local Agency Traffic Safety Academy. And it's been put in place. It's in the 6th year, providing information to your local safety issues to enhance your local safety programs. Like I mentioned, it's in its 6th year, and the webinars are usually on a Wednesday, and they usually are in a period of time from 10 a.m. to 12 p.m., which is a 2-hour window. And the minimum 1 hour, but no more than 2 hours. And depending on the complexity of the topic, it could go up to 2 hours. And then there's some links here that Anthony kind of went over already. As mentioned today is Systemic Approach to Safety. And we have another one coming up, Biking Facilities Intersections Part 3, and we'll have other ones for October, November, and December, and they will be posted, and you'll get a notification of it. And if you're a planner, AICP credits are posted out there for you. And if you're a professional engineer, you can apply for credit, educational credit. You download the PDH form and complete it, and there's a link. And Anthony's got it posted out there too, and you can also go to the web page. And with that, this is my contact information. If you ever have any question about anything related to the Academy, you can please call or send me an email. And with that, I want to turn it over to Chad and Robert.
Great, thanks, Dennis. So I'm Chad, just so you can apply the name with the voice. Robert and I are going to kind of tag team this back and forth throughout. This is really can be informal in nature, so we want these slides to make sense as we're going. So feel free to type in a question at any point, and Anthony, I think, will jump in and let us know the question, and we can get that answered for you, because we want to make sure this makes sense as we go. So can everyone see my screen? I think I just got a pop-up. I just clicked on show my screen. Does that,
Yes.
Anthony, are you able to see it, or if you weren't?
We can see the first slide of your presentation. You're good.
Okay, cool.
Looks good.
So this is a topic Robert and I are very passionate about. We work within the safety realm very consistently and enjoy all of it, and this is one of the ones we're probably more passionate about. I think we've had some really compelling results that you'll see. I think the presentation gets, in my mind, more interesting as you go. So if you can hang to the latter points, you can see some of the results, and I think it's the magnitude of some of the results is better than what we get in some of the other safety work we do. This is something that we still consider to be an innovative process. It's probably been around for, I don't know, 12 years, I'm guessing, but it's innovative in the sense that pockets of the country have delivered using this systemic approach, but others haven't. And Florida has in some areas, but hasn't done as much of it as some of the other states. So we present all this as one, I guess, from the public perspective, as something to consider in your toolboxes, a toolbox of approaches, and from the private perspective, just something to consider if you haven't had exposure to this before. So this is Robert and I. I'm not going to spend a lot of time on this one, but this will be in the slide handout. Should you ever have a question, feel free to reach out to either one of us directly. An overview, just quickly, of the slides. So we already kind of gave an introduction. Before we get into the topic of systemic, we're anticipating a broad audience. So for those who don't work every day in safety, Robert's going to give a little bit of an overview of the overall Florida crash perspective, so that you have that in mind as we go through this. Then we're going to talk about the process. We're going to talk about the workflow, and then get to some of the results. We'll talk about the local application, and then we'll have time at the end of this for questions. So we start the presentation with a quote, and we end with a quote. This one's from Henry Ford, and he said, "If you always do what you've always done, you will always get what you've always got." And that is by no means an indictment on the work we all do, but it's like I said, the purpose of this presentation is for those who maybe haven't seen this approach. This is something to consider, because the results are pretty compelling. So the goals, first, is to raise your awareness of the approach and how it can be integrated into a comprehensive safety program. I think traditionally, or for a long period of time, we largely worked within a reactive side of safety, and that was because we had to. We didn't have the tools and the computers and databases to the point that we do now that allow us to do some more proactive things. But starting probably in, as systemic became available, systemics more on the proactive end, and then with some of the highway safety manual predictive methodologies, that's also in the proactive realm. And to really have a comprehensive safety program, it's important to have the reactive and the proactive components. So this is just something from a proactive side of things to consider as part of a comprehensive safety program. The second is just to make you think. This is a transparent process, and it doesn't get as heavy into maybe some of the academia side as some of the other types of stuff that Robert and I work in. And I think there's absolutely a place for both. And the thing about this one is maybe the folks who aren't as heavy in the research side of things can follow this, even if they're not in the engineering realm. So So it's a transparent process, and it should make sense, hopefully, from start to finish. And that's one of the things I think from a public perspective that can be helpful in terms of public engagement and things like that. What is the systemic approach? This is a really long definition from the Federal Highway website, and I'm not going to read it. Even when I do read it, it takes a long time to process. So we're going to simplify it a little bit and just say it's a data-driven process that identifies safety performance candidates based on risk. So we've got two terms highlighted there. The first is the data-driven process, and because it's data-driven, it's repeatable. And I think there's not a preconceived notion of what the solution is, and the data drives us to the solution. So that's really why that's important. Risk, I think risk is a concept we deal with in our everyday life, but not necessarily, we don't necessarily think of roadways and highway and safety performance in terms of risk that often. And that's one of the things that this process does a very good job of, that kind of differentiates it in some ways from some of the other methodologies that are out there from a safety perspective. So we'll focus some time on that and explain the concepts, which really kind of takes the historical crash analysis we've probably all done before and takes it one step further to identifying the locations with most risk. Just briefly, a little bit on our experience. So we, as a company, we pioneered this process in conjunction with the Minnesota DOT. There was no name for it. It was a couple of folks from both sides who had back and forth over a period of time and just had some ideas, and it turned out to be something that was pretty effective. We've analyzed a whole lot of 65,000 plus centerline miles of roadway, a bunch of intersections, a bunch of horizontal curves. We've developed the FHWA systemic toolbox that's online on their website if you go to Federal Highway website, and we've developed a case study specifically for the use of this process and bike and ped crash types. A couple of unique benefits to the approach. As I mentioned before, this is a proactive approach, and we don't have a whole lot of those, so that can be, the potential to treat crashes before they occur is pretty unique and interesting. The deliverables, we'll talk about those a little bit later, but one of the things you get is you get a big, long list of site-specific projects, which is different than some of the other type of work we do, where maybe we identify countermeasures that are generic in nature, but we don't necessarily pinpoint those to specific locations to implement them. Or if we do, it's a small list, whereas with this process, you get a huge long list of hundreds or thousands of projects that are typically low-cost countermeasures that can be applied to these high-risk locations. We'll talk some more about Highway Safety Improvement Program. We've worked well with the local agencies. One of the things that they've told us is it's challenging. The resources are so limited in terms of budgets that it's challenging. I think when you start to get below maybe the DOT level, it's challenging for everybody, but when you start to get below the DOT level, I think it's harder to have a full-time safety engineer, or if you do, they don't have the bandwidth to put together as good of an application to justify HSIP funding as you would hopefully, as you maybe want. And so along with this defensible list of projects that I mentioned, we've actually developed an HSIP application for every project on that list, and it's led to increased results and success, if you will, in the HSIP application process. Some terminology. You'll probably hear Robert and I say systemic approach or systemic safety or systemic process. We're kind of using those interchangeably. So try not to get hung up on one or the other. We're really intending the same thing. With that said, you may also hear people talk about systematic safety, and I think in some cases the people use that interchangeably, but they are a little bit different. So we're talking specifically about systemic and not systematic here. One other terminology thing related to systemic is we've seen the term systemic used and have multiple definitions, and the way we're talking about it in this presentation is we're using risk to identify the locations that are most in need of countermeasures. We've also heard it, people just kind of applying a low-cost countermeasure and doing it to all the intersections or something like that. So that's the differentiator, is risk. We're using risk to try to find a minority of the network where we can address a majority of the crashes. Local road safety plan and county road safety plan, you'll hear us talk about those. That's really the deliverable that results from going through a systemic analysis. And so just understand that those are basically the same thing, but this is just the deliverable of the process. One of the questions we get frequently is, where can this approach be applied? And I think sometimes when people hear data-driven, they have concerns about, well, yeah, maybe it works at a state level or a county level, but does it work at a city level? We've been able to use it successfully for all three of the jurisdictions you see on the screen. Certainly the accuracy changes a little bit, but we've been able to get to statistically significant results regardless of the size. And we've even done one for the Seminole Tribe of Florida. There's 7 reservations, and they've got a very small road network, and we were still able to get some meaningful results. Similarly, people ask about the crash types that can be, you can use this approach for, and you can use this for all crash types and be completely comprehensive, or it's very scalable, and you can use it just for, vehicles or pet bikes or whatever. And I think that's pretty unique in this process. Or one of the cool things about this process is you can, if there's interest in doing something like this, but you don't have the funding to do it all, you can chip away at it, one crash at a time. And ultimately, it may not be quite as efficient from a budget perspective, from the amount of money it costs, but you can still do that and chip away iteratively to try and get to where you want to be. So this kind of is trying to set up the challenge, and you're going to hear us talk a lot about Minnesota throughout this presentation. That's because Minnesota is the location where we've done the most of this. We've used this process for every county and all 87 counties in Minnesota, and there's been some good results. And then we're actually going through a second round of it now for all 87 counties again, where we're taking a deeper dive. So we acknowledge there are jurisdictional differences between Florida and Minnesota, absolutely, but please keep in mind that this process works in both jurisdictions. We have complete confidence in that. So anyway, I bring that up just because there's some Minnesota numbers in this slide. But if you look at the Minnesota state system, the fatalities per mile per year, it's really low. And so trying to identify locations that have crashes can be challenging when the majority of the road network has 0 recent severe crash history. So kind of boiling that down and consolidating it, we have too many miles to address, and we just simply don't have enough money to address them. So enter this approach. This is, once again, one tool to consider for your toolbox to help chip away at this problem we all face. So I'm going to turn it over to Robert. Robert's going to give an overview, as we mentioned, of just general safety within the state of Florida and some of the numbers from the Strategic Highway Safety Plan. And then he's going to start and get a little bit into the workflow slide.
Thanks, Chad. Good morning, everybody, for everybody who's listening in. So what I'm going to talk about now is just basically a lot of regurgitated information from Florida's Strategic Safety Plan. And so let's just dive right in here. So this is a slide or a page taken directly from the SHSP. It's just a time series of the number of serious injuries and fatalities from 2011 through 2016. A couple things to notice here is that the trend for serious injuries seems to be fairly flat throughout the 6 years of data that we have. And The other thing to point out is that the number of fatalities, while it remains pretty flat from 2011 through 2013, you start to see a fairly substantial increase from 2014 and beyond. And so this is just kind of the current state of where we're at. Not entirely sure what 2017 has held in store, but this is just a slide from the strategic plan, diving a little bit deeper, breaking down the mileage, VMT, and fatalities as a percentage. 10% of the total mileage in the state is owned and operated by the state. On that 10%, we are looking at approximately 78% of the total VMT, and that accounts for 60% of the total fatalities. Conversely, when we just look at the local system, 88% of the total mileage in the state is owned and operated by the locals, and it still accounts for 39% of the total number of fatalities and 22% of the VMT. And so this slide kind of really sets up this first look at something called overrepresentation. And so while there's 60% of the total fatalities occurring on 10% of the total mileage in the state, that is a huge overrepresentation, and these are the kinds of things that we are able to identify using the systemic approach. I'm going to say overrepresentation, this term is going to come up over and over again, and we'll see some slides later on that actually graphically show where the overrepresentation is occurring. This is another graphic from the SHSP, and it's on the left side, we have serious injuries. On the right side, those bars are fatalities, and then going down the list is the emphasis areas that are identified in the plan. And what we notice here is that lane departure and intersection-related crashes stand out the most, with a huge number of serious injuries and a good portion of fatalities as well. FDOT has already used a systemic approach, or the efforts are at least underway, and preliminary results are pending. And so FDOT has already used the systemic approach on two particular crash types. And so Chad talked about before how this process is flexible in nature, and you can focus it to any specific crash type you want, or you can keep it as broad as you want, depending on the availability of resources that you have. So that was just the background, kind of the state of the system. And so now the next few slides that I'm going to talk about is the beginning process and the workflow if you were to apply a systemic approach. And so this graphic identifies three core elements of the approach. The first four on the right side are really just tying everything to the data-intensive parts, identifying the different crash types and doing a crash analysis. You have your network screening process, and you're basically looking at the network, whether it's intersections, segments, or horizontal curves, identification of selection of countermeasures, safety countermeasures, and then a prioritized process to deploy those countermeasures at. And then the second and third elements are basically the follow-up, where you're identifying potential funding sources, as well as evaluation of the countermeasures that you have deployed. And so it brings you back to that step one. So yes, this process, since it's data-driven, it's cyclical, it can be repeatable. We're updating the county road safety plans up in Minnesota for a second time right now. So we originally did those plans, I think, started back in 2008, and 10 years later, we're asked to do it again. So and we're still finding interesting things here. So the first step in the systemic process is we want to take a look at the crash data. And so this crash tree is a step that we use. We develop a crash tree, and what these little boxes are saying is, this example is you have any of the text that's in black is all crashes, and any of the text in red is severe crashes, and as a percent to the right of it. And so there's a lot of stuff going on here. I'm not going to walk through every single one of these, but essentially you start at the very, very top and you work your way down. And as you work your way down, you branch off into different jurisdictions and different environments. And essentially what you're doing here is you're breaking up crashes into homogeneous types of crashes. You want to be comparing apples to apples when you're looking at your crashes on your system. And so what I've highlighted here is we separated out segment and intersection related crashes on the rural system. And what we go even further, because one of the reasons why we want to separate out segment and intersection related crashes is because the crash types are so different, and the countermeasures that we would suggest for these different locations are different in nature as well. And so if we look at the right side, breaking down the intersection related crashes, we have found here that approximately 43% of the right angle crashes occur at through stop or through yield controlled intersections. And so if we look at the right angle crashes in particular, we're seeing that it's 43% of the severe crashes, of severe right angle crashes, and that's an overrepresented proportion compared to the total number of crashes. So here's that concept of overrepresentation again, where we want to be able to, we're able to identify where there's a majority of severe crashes. And since the performance measure that FDOT uses is severe crashes, severe being fatal or incapacitating injuries, that's what we want to focus on. And then similarly on the segment side, on the left side of your screen, 17% of your severe head-on crashes are a subset of your lane departure and along your segments. So I'm going to pass it back over to Chad for now, and the next slide here is just going to be a risk example, kind of setting up the playing field for risk.
So I mentioned this concept of risk and how this really differentiates systemic versus some of the other approaches we use in the safety realm. And I'm going to walk through an example here. If this were a live audience, I would ask for answers, but I'm going to walk through kind of the typical response we get to some of these questions. And we're using this example to try to paint the picture of risk and how we can use risk to help improve our safety performance on a road network. So if you had a two-lane undivided roadway that had a rural typical section and a design speed of 50 miles per hour, and you were looking at a horizontal curve, the FDM would tell you that the minimum radius that you can use is 716 feet. And that if you use that minimum radius, you need to have a super elevation, the banking of the road of 10%, which is the maximum we can use. So if we have two curves, curve 1 and curve 2, and curve 1 has a radius of 500 feet, that's well below the minimum radius that's allowed, so you would need to get a design variation or potentially an exception. This is already in place, so it has a super elevation value of 8%. And then you were looking at curve number 2, which is similar but a little bit different, or has a radius of 550 and an E value of 8.5%. If I were to ask which, is one safer than the other, this usually causes people to pause a little bit, but ultimately the response that we most consistently get is that curve 2 is safer, and the reasoning behind that is that the radius is closer to that nominal value from the FDM, and the super elevation is closer. So then we kind of peel one more layer of this onion off, and we say, okay, well, if we now told you that curve number 1 had the 5-year crash history, had 0 fatalities and 1 incapacitating, so 1 severe crash, but curve number 2 over the same period of time had 3 fatalities and 2 incapacitating, and we ask you the same question, the answer is going to change, right? Because clearly curve 2 over the last 5 years has performed, the safety performance has been significantly worse than that on curve 1. So let me backtrack. So up to this point is a pretty traditional, the historical crash analysis that we've all probably undergone. But I think this is the point at which we take that extra step and start talking about risk. So the next question becomes, which one has more risk? And even though curve 2 over 5 years may have had more severe crashes, if you were to look at a risk, consider the risk profile of both of these curves, they're both pretty risky. They both have significantly lower radii values than we're required to have, and they both have below super elevation values. So if you think about that, the risk moving forward, I mean, 5 years is good information for us to use, but if you looked at this over 50 years, would the larger sample size cause the number of severe crashes to sort of become closer to equivalent between these two? And I think, it very easily could be that curve number 1 and curve number 2 could flip in the next 5 years. And maybe you have 4 or 5 severes on curve number 1, and you have 1 or 2 or 0 or whatever on curve number 2. So this concept of risk is more forward-looking. It's proactive in nature, and I think a good parallel to this that actually Joe Santos passed along to me, the state safety engineer, was to sort of think about the concept or just human health. We don't necessarily think of roadways and highways in terms of risk that often, but we use it every day with human health. So if you were to go to the doctor and say, hey, Mr. or Mrs. Doctor, am I going to have a heart attack? Well, they're probably not, they're not going to tell you yes or no. They're going to say, well, here's some risk factors. Do you drink a lot? Do you smoke a lot? Do you eat red meat? Do you exercise? And depending on your answers to those questions, they're going to tell you you're at high risk or you're at low risk or wherever you are sort of in the spectrum of the risk based on what they know. And so, and I guess finishing up the human health discussion, we don't just treat the people who have the heart attacks. We want to identify the risk elements, and we want to give them blood pressure medicine or whatever it is ahead of time. And I think, so this is kind of unique. A unique way to approach roadways is this concept of risk, and how can we identify the risk even if that 5-year crash history doesn't show it, and proactively treat those locations. So the next step is we work with the client to identify a list of potential risk factors. So we typically do these analyses. When we do a systemic analysis, we look at intersections and we look at segments and we look at horizontal curves, because as Robert mentioned earlier, the types of crashes and the severity of crashes you see with each of those is different. And so, so this is an example of rural intersections, because, and let me just, I guess, backtrack a little bit, because this is Minnesota heavy, some of these slides, we talk a lot about rural and not as much about urban, but this works in both environments. So just be aware of that as we progress. So circling back, we work to identify a list of potential risk factors. And this is one that this is 44 potential risk factors here. And we do a rigorous statistical analysis to try to look at these overrepresentations like Robert was talking about. And what we're trying to, so we'll do this analysis for every one of these potential risk factors. And then we determine the ones that have the strongest correlation to safety performance. And once we do that, we throw out the ones that don't have as strong of a correlation, and we just look at the ones that do. And so for this analysis, we worked with the client to identify what they wanted to look at. And after we looked at it, it was determined that 6 of the 44 potential risk factors had the strongest correlation to safety performance. And so that's adjacent curve, whether or not there's adjacent development, alignment skew, traffic volumes, on and on. So, so then what we do is once we identify, okay, there's 5 or 6 or 10 or however many risk factors, we then, using the same information we use to identify the the actual risk factors, when we kind of the screening process earlier on, we identify a threshold with which once you get above this, that's when the safety performance begins to severely degrade. So on the analysis we just showed, when the skew angle of an intersection got to 10 degrees, that's when the safety performance really started to go down. So what we do is we take these risk factors that we've now determined, and we take the tolerances that is that tipping point to where the safety starts to go down. We take a big step back and we proactively analyze all the intersections or segments or curves, in this case intersections, and we identify, okay, we go intersection by intersection, and everyone that has a skew angle 10 degrees or higher gets a star that means that it triggered that risk factor. And for the volume cross product, when it was 400,000 or more, then we gave a star for that. And so we do that for all of these risk factors that we've identified. And what you wind up getting is the starting of a prioritized list of projects where, locations that have the highest risk versus the lowest risk. So you could start to prioritize your resource allocation moving forward. This slide may be a little bit out of place, but it's an important slide. And it's just pointing out that as we go through this process, one of the things we've done is work with the locals to hold a one-day workshop. And we invite law enforcement, we invite the 4 E's, we invite politicians, and we walk through this, we walk through the process, we walk through the results, we walk through the risk factors we've identified, and it's a day-long workshop, and the purpose is really to achieve stakeholder input and buy-in. And I think this is where earlier on, when I was saying that this is a very transparent process, this is the point in which one of the points where it becomes really important, because you may have people in the room that don't deal with safety every day, and it helps when as we walk through this, when it's transparent and it makes sense, it helps to get their buy-in. So anyway, that's an important part of this process. So after we walk through everything, we get to, okay, we start to work on this prioritized list, but right before we do that, we do a validation exercise. And so we've got 2 different examples here. This one's for rural 2-lane intersections. So what you have is on the y-axis, you have a percentage of the network. So each of these bars represents a different crash type or a different set or subset of crashes. And if you add up each one of these bars, all the light blue are going to add up to 100%, all the gray are going to add up to 100%, and so on. And then what you have on the bottom is basically a distribution of all of the intersections that are being captured here. And there's some percentage of the intersections that had 0 stars, meaning that there were 0 risk factors present at that intersection as defined per the tolerances we found. And then you have 1 star, and you have all the way up to 6 stars. The 6 star is going to represent the most at-risk intersections based on this analysis. The line that has the percentages next to it, that represents the percentage of intersections that have each one of these, the number of stars shown below. So 16% of the intersections had 0 stars, no risk factors. From a relative perspective, is a much safer intersection probably than the ones to the right. And 28%, 31%. So you can see all those add up to 100% as well. So the light blue bars represent total crashes. The gray bars represent, percentage of total crashes. The gray bars represent the percentage of severe crashes, and the darker blue-green represents the percentage of severe right-angle crashes, and that's shown just because that's a prevalent crash type at intersections. So if you start to look at this, and this starts to hit on this concept of overrepresentation again. So we use these type of charts to identify the overrepresentations, where a majority of the crashes occur on a minority of the network. And in this case, what you see is if you look at the 3-star or more intersections, and you add up those percentage of intersections, you're looking at 26% of the total intersections that were screened, but that represents 65% of the severe right angle crashes and 55% of the severe crashes. So this is the magnitude of this is pretty compelling, and I think it really helps when you go back to that challenge at the beginning and the problem that, how do you identify when there's so many crashes and so few crashes, and we want to have 0 obviously, but relative to the density on the network, the crashes are, they don't occur everywhere. And so how do you identify those locations? And that's what we use. So what you see here is very similar if we take a step back to what we do for each one of these risk factors. When we identify, yes, it is a risk factor, or no, it's not, we look for these overrepresentations using a similar type of chart. And that's how we determine the value, the 10-degree skew value or whatever. So taking this a step further, similar, a different way of looking at the same information. This one has crash density on the y-axis. So that's crashes per intersection per year. The light blue is still total crash density, and the green is severe crash density. And then similarly on the bottom, you have, 1-star intersections, 2-star intersections. So if you just compared 1-star intersections, which I think were 28% of the intersections, to the 6 stars, which represented less than 1% of the intersections, you'll see that the 6-star locations, the ones that have 6 risk factors present, less than 1% of the network, those are 10 times more likely to have a crash than the 1-star locations. And looking at severe crashes, it's actually 40 times more likely to have a severe crash on those most at-risk locations than you see at the 1-star intersections. So that's the validation exercise, and then we get into this. This is a list of candidate projects. So this is the start of this prioritized list. It's not quite site-specific projects yet, but we're identifying this one is for rural 2-lane paved segment. This was pulled from the Seminole Tribe systemic analysis we did. So there were 6 risk factors that were identified, and what you start to get is if you look at just the top 3, the top 3 had 5 out of those 6 risk factors. So we identify these candidate locations for projects, and then we move into and we begin the start of this prioritized list based on the risk that is present at each one of these locations, and then we work to identify countermeasures. And we largely try to focus on low-cost countermeasures. However, if there are some areas that have really high crash densities, we will sometimes include mid-range or more costly countermeasures in that list. We include the cost of the countermeasure and the effectiveness when we bring this to the client so that they can be informed, and we work with them to make sure that they're happy with these countermeasures. Sometimes we find that there's a particular countermeasure that a jurisdiction or an agency has tried to implement but hasn't had success with, so we'll throw that one out if that's what they want to do. And here's just one example. So sticking with the segments, for rural segments, just picking one strategy was centerline rumble strip. The crash reduction factor is 40%, so the CMF is 0.6, and the typical installation cost for the one we were working on was about $3,600 per mile. So we use those countermeasures and apply those to the sites, the candidate locations, and that's how we identify actual site-specific projects that we recommend for implementation. So this is when I talked at the beginning about really the compelling results. This is kind of the proof. And so this is a chart showing the results of the county road safety plan. So when we did the first round in Minnesota, we did it for all 87 counties, and that represented all of the county road system. So what you see here in this chart is a breakdown of the county, state, and interstate jurisdictions And on the y-axis, you have the fatality rate in crashes per 100 million vehicle miles. And on the x-axis, you have just the trend, the year, it's data point by year. So our efforts focused only on the county road system. The vertical line, as Robert indicated, we kind of started the process around 2008, and roughly 2011, 2012 was about the point where we had finished and produced and delivered a report for every single county that this was the county road safety plan, this deliverable for using this approach. And that was the point at which they actually started to begin the implementation of the recommended projects. And so that's that vertical line, is the begin point of the widespread deployment of safety strategies along the county system. And what you see is, since we only focused on the county system, there was a 26% reduction in the fatalities on the county road system in roughly 2 to 3 years following the beginning of the actual project implementation. And this is doubly compelling to me when I look at this, because not only is there, 26%, that magnitude is just something we really don't see in other safety work we do. That's significant. And I think from a Minnesota perspective, 50% of the road network or 50% of the fatalities occur on the county road system. So, this process reduced the number of fatalities and within the whole state by 1/8. So that's really significant. And so where the compounding, that I circle back to my point about compounding, is what you see typically is these jurisdictions go up or down together because of a number of factors, but one would be the economy. When the recession happened, less people were driving, and so the fatalities went down as a trend on all of these. But what you're seeing here is the county road system is actually bucking the trend. And so the state and the interstate over the 3 years after the deployment, those are going up, but the county roads going down. So I think that's even probably greater than this 26% reduction. So one disclaimer to add on there, this process absolutely works for both a rural and an urban environment. It's a little more effective in a rural environment. The road network in Minnesota is more heavily rural. I think in Florida, we've got 65% of our roads are urban, and 20% are rural, and 15% are not classified. So that's way more significant urban than what you have in Minnesota. So this will absolutely work. But, in an urban environment, maybe it's 15%. I don't know. I'm just throwing that out there, but it may not be 26%. Some industry acknowledgement. So this is kind of just, don't take our word for it. The North Dakota, we did this for every county in Minnesota, every county in North Dakota. We've done it in New Jersey and other pockets of the country. Both North Dakota and Minnesota won national level safety awards for the county road safety plans that were developed. This approach will be included in the second version of the Highway Safety Manual. We are Robert and I work on a contract that's providing technical support services for the development of the second version of the Highway Safety Manual, and we got the okay from the AASHTO PM on that to make the statement that it will be included. And then also, there was a separate webinar maybe a month or two back that was on local road safety plans, and that was subsequent to FHWA approving a local road safety plan as a proven countermeasure. So Robert's going to come in here, and then he's going to speak to this local application, and then we're almost done.
So what this slide is showing is what we developed in one of the final products, in addition to the actual safety plan that we developed for any local agency, is an HSIP application. And I know the HSIP application process is different in every state, and what we found to be the the best thing that kind of really came out of this whole process was getting the feedback from the county engineers in North Dakota and in Minnesota, saying how easy it was for them to apply for this funding. And going back to that problem that we looked at the beginning is, we just don't have enough money. Well, HSIP is a great program to supplement the agency's capital improvement program. And so being able to develop, hundreds or thousands of these HSIP applications that all you have to do is just take your plan, flip to the location or the page that you want, rip that page right out of your plan, or make a photocopy of it and send it on up, and maybe do a little administrative work on it. We basically develop these applications to about 80% complete, and so we do the majority of the work for the local agencies up front as part of the process. And so this is just really, it's breaking down the barriers to adding federal dollars to your local system. And so it's just been the feedback that we've received has just been, it's easy, and it almost kind of pays for itself.
I'm going to just interject one thing real quick. We have worked with other states to incorporate this automation of the HSIP application. That's not something we have done in Florida. So I want to be cautious to not commit that FDOT is okay with this. We've had preliminary discussions with Joe Santos. We haven't discussed it with Peter Hsu about would this be something you would consider. And Joe said, yeah, he'd be willing to talk about it. But I don't want this slide to paint the picture that this is something FDOT is 100% okay with yet. We don't know that for sure.
And there's liaisons out there too that I know assist with the application process in general too. So we're here in Tampa in District 7. So let's just kind of start the process from the beginning, looking at here's just what's going on in District 7. This is severe crashes from 2012 through 2016. Broken down into each of the counties here in the district. Hillsborough County, no surprise that it's got the majority of the severe crashes. There's a lot of people that live here, and so from that data, we also start. Here's a preliminary crash tree. The red text and the red numbers indicates a traffic fatality. The non-bold black numbers indicate the incapacitating injuries, and then cumulatively the bottom numbers is just the sum total of those. And so here's a breakdown in a preliminary crash tree, and for each of the counties, and then taking one step below it, we're looking at intersection and non-intersection related crashes in each of the counties. I'm just going to look at Pinellas County, focusing in on this. What we can see here is that 56% of their severe crashes occur at intersections compared to non-intersections. And I think Pinellas County is, one of the most densely populated counties in the state. And so just based on the characteristics and the analyses that we've done, and it almost kind of makes sense that the majority of severe crashes would occur at intersections in a very densely populated area. Here's a graph looking at the entire state of Florida, and we are specifically looking at bicycle and pedestrian related crashes from 2012 through 2015. The y-axis is a percentage, and the x-axis is the 7 districts here in the state of Florida. And so we've seen this kind of chart before, and what this is identifying, or what we're trying to look at here is the green bars is the total pedestrian and bicycle related crashes, and the gray bars are the severe ped bike crashes. And if you look at the percentage bubbles that correspond to that dashed line. If you add up all those percentages, you'll get 100%. Same thing with all of the percentage of crashes in those bars. If you add up all the percentages of the bars, you'll get 100%. And so what we're trying to look for is this concept of overrepresentation again. So where the bars go above the line, that's your overrepresentation. If we look at District 7 over on the right, that gray bar reads just over 20%. So 20% of the severe ped bike crashes are occurring on 13% of the public road mileage. And sorry if I didn't clarify that. So yeah, the line is the public road mileage. So it's just the number of miles in the state. And so here's that overrepresentation again in District 7, District 6, and District 4. And so doing this high-level crash analysis, we could say maybe, okay, if we were to tier the state into trying to focus on where should we focus ped bike related safety improvements first, I would say Districts 4, 6, and 7 would probably be your first tier because the crashes are overrepresented compared to the system. District 5 would be your second tier just because that's basically at representation, but you're still talking almost 20% of the severe ped bike crashes are occurring in District 5. Then a third tier would be Districts 1, 2, and 3. Since the bars are below the line, that's an underrepresentation. Not to say that we don't need to, or we need to ignore it or whatever. There's still too many crashes in those districts, and it would just be a lower prioritized tiered because we're dealing with more of the system, more of the public road mileage compared to the crashes. So the crash density is just much less in those districts. And so if we take a closer look at District 7 in the different counties, we see this concept of overrepresentation again and underrepresentation for Citrus and Hernando, but Pinellas County and Hillsborough County and Pasco County, for that matter, are all overrepresented for severe ped bike crashes compared to the system. And this is just some data that I was curious enough to download from SSO-GIS, and so you can go and create the same graph if you choose to as well. And so a couple other just quick facts about some ped bikes. So a bullet from the ped bike page in the Strategic Highway Safety Plan is that while Florida has only 6% of the U.S. population, it unfortunately accounts for 17% of the bicycle fatalities and 11% of the pedestrian fatalities. And I think Chad mentioned before that Jacobs developed a case study for a ped bike systemic safety study for FHWA, and in those county road safety plans from Minnesota, we were able to look at an urban environment and suggest over 700 ped bike specific projects at an estimated implementation cost of around $6 million. And so there's been, any kind of environment, any data availability issues, like we've always been able to come to some meaningful conclusion and statistically reliable results, regardless of the jurisdiction or built environment. And so speaking of these results, like we said before, we've looked at over 65,000 centerline miles of road, over almost 30,000 intersections, 30,000 curves, and with all the analyses that we've done, we've accumulated a rough estimate of about $720 million worth of suggested countermeasures to the different agencies for them to deploy. And obviously, that's going to take a long time to try to implement every single one of those. But the beauty about this process is that it's a prioritized list. So if you start from that top of your list, you're going to be addressing the majority of the crashes at the minority of your system. And so it's a good thing here. So other deliverables and benefits from this systemic approach is the specific agency, or the agency will get a agency-specific plan it's catered to them. We work really closely with whatever agency, and you know, if they want this included or that excluded, we'll do it. And so then there's, you know, increased success in applying for HSIP funding. Like I mentioned, the local feedback has been really positive, and a location prioritization of countermeasure recommendations and this defensible project list is just key. And the other component of it is really involving the 4 E's of traffic safety and getting that stakeholder engagement and that local buy-in. We started with a quote, and so we're going to end with a quote by really famous basketball coach John Wooden. Failure is not fatal, but failure to change might be. And with that,
so that ends the presentation, and Robert and I are available for any questions any of you have. So.
Hit 1 hour.
There was only one specific question that came in the chat on one of your figures, so I let you guys continue down the roll. But if you can go back to slide 41 and 42, there was a graph that showed intersection, non-intersection, and other. What is other? You know, the person saying, I mean, if it's either an intersection or it's not, and there's a third category. What is that?
It's based on the different options that is coded by the reporting officer. And so sometimes it's, you know, when you have 7 or, you know, 8 different options to fill in one field, sometimes it's just an other, or it's an unknown, or it's left blank or something. So the majority of these numbers and the percentages can be identified as either intersection or non-intersection, but there is a percentage of it as being other.
And I suspect, yeah, I don't know this, but Robert and I always really enjoy discussions with law enforcement because they allow us to fill in some of the gaps that we may see from the office perspective. But you know, one thought that enters my mind is it could be in a location where the officer's just not sure whether to code it as an intersection or a non-intersection, and so that's just the path of least resistance for them.
Yeah, an incomplete short form, perhaps a parking lot, or yeah, I mean, it's just something.
True.
Something. Yeah, I mean, I understand logically. It's like it's either an intersection or it's not. How can there be another? But when you're dealing with crash data, people filling out police reports, there's things that happen that require an other category. There's the District 7 did chime in with a couple of comments when you were talking about Joe Santos and Peter Hsu. Peter wrote in a couple of comments saying that U.S. Congress FAST Act places limitations on highway safety program money usage to focus on fatal and severe crash reductions. So, you know, the HSIP and performance measures, the final rules of the federal, I mean, it's the things have been signed that require that reduction in the fatal and severe crashes. So I think that there's not clear direction yet on the systemic safety approach due to these FAST Act rules. I mean, are you guys aware of anything that, you know, anything different besides what he's saying? Because it's part of the conversation that you and I were having prior to the webinar before we went live. You know, the challenge that we keep coming across when we're trying to identify systemic approaches. You know, looking at the geometry, looking at all these things, and it's a great approach, but it always comes back to, well, what's the specific location and what's the benefit cost? You know, how many fatal and severe injury crashes are you fixing? I love the idea of treating locations as a patient, you know, and fixing the risk factors. But, you know, when you have actual locations that are having crashes, you know, how do you justify, you know, fixing a location that has risk factors but no crashes when there are locations that are actually having crashes? Maybe that's another way of rephrasing the question.
Sure. I mean, obviously, this is an interesting discussion point, right? And I can say from other states' perspective, they have submitted HSIP applications based on these analysis and have, what we said in there is accurate from their perspective, that they've had increased success. We've done an analysis. Well, first of all, that curve 1, curve 2 example, that's hypothetical, and that's made up as an exercise to make people think. It's probably extreme. Now there may be a few locations where you literally have that big of a swing, but I think what's probably more realistic is you have a location that falls just outside of your high crash list. So maybe you're not identifying it as one of the target locations, but it's very close, and the understanding of the risk and the fact that moving forward, it could be there could be a more significant number of crashes there, I think, is there. So understand there's a few of those cases, but really not a lot of them. They tend to be closer to, anyway, hopefully that makes sense. But the other thing is, Robert and I have looked at, and this is Minnesota data again, but we looked at kind of post all this systemic process in this first go around. We looked at the percentage, the number of fatalities and incapacitings that were being targeted using the high crash list compared to the percentage of the roadway network, and we compared that to the network that we picked. I think some engineering judgment, we picked 3 stars and above or something like that, and what we found was you were addressing a higher percentage of the fatalities and incapacitating injuries on a lesser percentage of the network. So I think there is a way to show that. Now this is showing post results, which you may not have during the HSIP application, but I think there's a case to be made that you're getting a higher density of crashes in over a smaller portion of the network. I don't know, Robert, do you have anything to add to that?
Yeah, so looking at, if you're to just look at high crash locations, we did a systemic analysis and we consider those high crash locations as any other intersection that we're analyzing. And when we only looked at the high crash locations after the fact, the process was still able to identify a greater number of severe crashes on a smaller proportion of the high crash locations. So I thought it was really interesting because even though the state was able to identify, hey, this is a high crash location, we were still able to run our analysis and identify where you could prioritize your high crash locations other than just using historical crash data.
And I'm going to speak directly to, I guess, Peter and FDOT here. If to some degree, some of this information is hard to get through over a phone conversation, but we've got a spreadsheet where we looked at this and it gets pretty complicated. But if that's ever something you're interested in seeing, we can certainly show that to you, and it paints the picture a little bit better than we can do over a phone conversation.
Sure, he's on the line right now. I'm sure he's going to follow up because I mean it's definitely something. If they get direction from up above and like FHWA saying this is good and that's the direction from DC and everything, then central office and it all kind of trickles down because our hands are somewhat tied by the rules that we live by. I mean that's in my experience. You were talking about looking at the high crash at the high crash locations, and what you end up identifying in a lot of cases, if you're looking at only crash frequency, it's just your high volume locations. You're just finding your 6-lane roads where they intersect with your 6-lane roads, because with more exposure, you'll end up with more crashes. I love the idea of finding it geographically and by the geometry of the locations, prioritizing based on the risk. It's almost like normalizing the data against volume and calculating rate. Taking your risk assessment is normalizing the data against the geometry of the intersections. it's a really interesting approach.
Sure. One other thing I'll offer up to FDOT, if you don't already have these relationships or know these folks, we could certainly put you in contact with someone like Brad Estoshan, who's the state safety engineer at Minnesota DOT. He's been very proactive and has made himself available to talk about this stuff because they've had such good results. So, that could be something where someone like a Brad or in another state where they've maybe have been able to use this process for HSIP successfully, we could certainly maybe catalyze a discussion so that Peter or others could pick the brains of those people to see how they've been able to make it work.
So for an agency looking to start, a prioritization process like this, just for clarification, it took 4 years in Minnesota to when you guys began to when you actually said, here's the plan and start implementing things. It was 4 years. I think that's the number from the chart where you guys showed, the trend and, when you began the work and when the crashes started going down. So it's a long-term commitment. But where do you start? I mean, do you kind of do you pick a countermeasure, fix that everywhere? Do you pick a corridor and fix locations and regions, with your prioritization, or do you fix one geometric configuration and fix that intersection type everywhere it exists? What's the best approach? Kind of a combination of all of them?
I think, in short, I think it probably would be a combination, but I really think you should just start with looking at crash data and what's on the screen right now. Actually, you're able to identify, do we look at intersections or do we look at segments at first where there's the majority or the greatest accumulation of them.
And the 4 years you're quoting is totally accurate based on our discussion from the presentation, but that's 87 counties. So any individual county is probably in the range of 12 to 18 months, depending on how dense the data is and how many risk factors you identify. And certainly there's an upfront data collection component. The more readily available and accurate the information is at the start, the more quickly all of that can get going. But understand, a lot of those counties, 4 years was really kind of after all the counties were done. So yeah, I think they prioritize counties kind of the same way we're prioritizing this stuff. The ones that had the highest densities, it may have made sense to start at first. And
in the first round of the county road safety plans, they broke it up by district or by ATP. The second time around that we're updating their plans, it's actually based on who has completed most of their plan first. And so in this first phase, there's 15 counties, and those 15 counties were clearly the most progressive and the most proactive. And the county engineers, they were the ones basically championing this effort to really make that change. And so it's it's a phasic kind of process. You can't do all 87 at once, but there's multiple techniques we've shown here. Crash trees, looking at an overrepresentation of severe crashes to the percentage of road miles. There was the discussion in Ped Bike about the population. There's an overrepresentation of the Ped Bike crashes relative to the U.S. population. And so those are the type of things that guide us in the direction of kind of where do you start. And so that would be my recommendation, but certainly at a client level, there may be reasons to do something else first. If you have a very proactive county road safety, if you're doing it at the county level and you have a very proactive county engineer, you may want to start with that county because you can get it done more efficiently and and they'll start going on the results, and you can start to show the public the success you're having, and maybe you can get some of the others to follow suit afterwards. So anyway.
With regards to the risk factors, I'm not aware of a comprehensive sort of intersection list for an inventory that pulls the risk factors from did you guys find a golden goose in Minnesota where, like, you know, all these risk factors were kind of already itemized for you, or is this part of the process for, you know, you actually go out there and do a good bit of data collection and identify the risk factors and do some field inventories and figure things out and build that database so that you can prioritize your things from?
Believe it or not, the key was interns. So a lot of manual data collection using aerial imagery or you know, photo logs or any kind of video logs or something like that. Like we go into this process, and you know, if the agency wants to look at, you know, if everything is on the table, then all right, well, we're going to start with, you know, what's out there. You know, those 44 or 45, you know, potential risk factors. Those were data elements that we had to go collect. Some we were able to automate, like you know, traffic volumes, for example. But however, you know, I don't know if every agency will be as data rich to be able to provide, you know, skew angle at every single intersection with, you know, the approach turn lane configuration or signal head placement. You know, it's definitely a labor intensive process, and the data analysis portion of the project, or you know, of the entire approach, should not be undercut at all. Like that's where you get the most of your meat, and potentially where you can find some things where could very well be counterintuitive.
And are you maintaining that database, or is that something that you kind of collected at once and then you have a static view and that's what you do your prioritization from? Because things are always changing out in the field.
Yeah. So, for example, we did a systemic analysis on Minnesota's state system, and with the horizontal curve database that we provided to them in, you know, a file geodatabase, they were able to use all of our data and basically screen the entire state system and identify where they needed to place advanced curve warning signs and speed plaques based on the updated MUTCD guidance for the speed differentials within a curve. And they said they were originally going to have, you know, one of their engineers take, you know, 6 months to do it, and he wound up using, you know, a couple different pieces of software and Access database or whatever, and he wound up doing it within a week.
And I think we're fortunate in within the state of Florida. I think FDOT has done a very good job of their inventory of different features and roadway geometry is very robust. And so even some of the things that maybe haven't made it into GIS layers yet, I believe you could use straight line diagram information and sort of overlay it with GIS and create you know, intersection I mean, they already have intersections, but that's not a good example. But I think you could combine those to quasi automate something as opposed to manual data collection. So that's one of the benefits we have here.
Yeah, the RCI has a good number of layers.
Yeah, and the other thing is that this process is so scalable, and there's so many different ways you could choose to prioritize things. We've usually worked with the client to identify all the risk factors they want to look at, but in reality, you could just focus on the ones that don't require manual data collection, or you could just narrow it down to a subset of a couple of manual data collection that you know are critically, you know, or have a strong correlation to safety performance, and you could get meaningful results. And maybe it wouldn't be quite as significant as it would be the other way, but it's sort of low-hanging fruit, right? And so your upfront investment isn't as significant, and you can still go start to make those improvements. And then if you have the success, maybe you choose to do the manual data collection later. But is MnDOT maintaining the inventory from all the manual data collection from this point forward? We are not maintaining that.
No, I think, yeah, I'm not sure what MnDOT's doing with it, but yeah, there's a good chance that they're using it themselves in their own way.
One can only hope, yeah, because I mean that would be a shame for so much data collection and all this, I mean, but then just 5 years down the road it's completely obsolete, and it needs to be done all over again. That's one of the challenges. I'm aware of a few agencies that have tried doing like a signal inventory with the approach configurations and it's a protective permissive, it's in a 5-section head, it's in a flashing yellow arrow, and they get a jurisdiction done, and 5 years later it's like, well, this is useless now because no one maintained it. So the maintenance of the data is kind of a key component of this as well. Are you aware, other than Jacobs, of any other large-scale systemic safety evaluation projects that you guys did in Minnesota? Like, if anybody out there doing other kind of like to compare and contrast the approaches?
Sure. I think at a lower level, I mean, I've seen Seattle's done ped bike. I want to say Kittleson did that one. I know Cambridge has been involved in some. I don't know the exact locations. Ohio DOT has been involved in some. New Jersey DOT. MoDOT, Missouri DOT has done some. And they actually set theirs up a little bit different. I think they kind of went through the research portion of their procurement, and so they were able to make price one of the scoring components. And I think that may not have led to quite the results they wanted on that one. But there definitely are. But like we kind of said up front, it's pockets of the country, here and there. But not everywhere yet.
Yeah, and it's something that's coming to the version 2 of the Highway Safety Manual. So I mean, everybody's going to start doing these pretty soon. Are any of these projects? I mean, not to have you guys promote y'all's competitors, but I mean, at least the work in Minnesota, the reports, the completed plans, are they available online anywhere where the people that are listening now can go to the website and kind of download the plan and see what it looks like and get some ideas?
North Dakota has published all of their county road safety plans. We also did a plan for the 2 national parks as well as the 4 Native American reservations. And so those are all publicly available on North Dakota DOT's website. Minnesota's, I think state aid gave the counties discretion as to how they want to provide their plans.
Okay. Yeah, but if a safety engineer in Florida contacted the Minnesota safety engineer, they would probably share that information with them. They would just have to build that relationship and get the information.
Yeah, based on our experience with Minnesota DOT, they're very open to sharing. I think within safety, most agencies are. But yes, if someone were to reach out to Minnesota DOT, absolutely. RPM, the one that I mentioned, kind of pioneered this process up in Minnesota. So Robert worked under him for 4 years. If it would help, he certainly got all the relationships with all the county engineers and the state safety engineers. So anyone at FDOT can go straight to anyone at MnDOT, or if that helps, we can catalyze that. North Dakota DOT, Robert can send, Anthony and Dennis, we can send you a link to where those are. I guess, is there a way for you to distribute the link if we send it to you, to the listeners?
Yes, we can do that.
Okay. So obviously that's going to be much more rural. I think Grand Forks is probably the closest one to
Bismarck, maybe.
Grand Forks and Bismarck are probably the closest to an urban environment, but very different than Tampa. But yeah, we'll send those along. Yeah,
and anybody wanting to be linked up with the Minnesota guys can contact them directly, or I mean, they have your contact info, so you could also forward that to them. So the person that asked that question can just shoot you an email.
Absolutely.
In the 3-step process, in your identification, funding, and evaluation process, which step would you say that the agencies kind of need the most help, or is the most challenging, or has the biggest pitfalls? I mean, it's a nicely laid out kind of circular process, but where are you guys finding your hiccups?
In the you said for the HSIP process, or just in the process altogether?
Like in your systemic process, there was the wheel that shows the three steps, the three elements rather.
Yes.
Yeah.
Yep.
Honestly, when it comes to implementation, because really that's the key thing here is really finding the right projects for the right locations and actually implementing them. And so some of the biggest hurdles that happen early on is data availability. The hurdle maybe later after the technical analysis is, the selection of particular countermeasures. Sometimes there are certain politicians or there's, the public saying like, hey, we don't like this, we don't like shoulder rumble strips or whatever because it's noisy and we don't want it outside of our house or something. And so you have to try to get that buy-in and really engaging locals and engaging stakeholders as well. So that's the second one. And then the third hurdle could very well be, just at the state's discretion or, following in accordance with the FAST Act or any sort of, national legislation that, it's how to actually get it funded and using this process as a vehicle to get that project funded.
And I would add on to that last one. I think there's an upfront challenge, and I have a large appreciation for it, I guess, as much as I can without having been in the position. But I think, or I suspect, as someone who's overseeing the funds and the implementation of this stuff, we don't get as much money as we'd really like to have, and unfortunately, the industry doesn't prioritize safety as much as we say we want to. And I think, so sometimes just making that first dive into this is really challenging because we're making improvements elsewhere. They may not necessarily be to the 26% order of magnitude like we talked about, but it's like, okay, well, it worked in Minnesota, is it going to work here? I mean, we know it'll work there, but that's a really challenging question to answer. And I think sometimes, it's easy for me to say, well, let's think in terms of, yeah, you could have this huge reduction. But I think the other side is, well, what if it didn't work, right? And now I've diverted safety funds away from something that was proven and that I know worked. And I've never had to be that decision maker, but I suspect that's a really challenging position to be in because people care, they're really passionate, and this is an easy topic to be passionate about. And that's a leap of faith, the first time you do it.
We've kind of talked around this topic. This question is phrased slightly differently, so maybe we'll get something else out of it. But it says, with the systemic approach, how do you overcome crash sample sizes becoming smaller as you drill down to your specific comparisons, by countermeasures or when you break your things down so you're doing your apples to apples comparison? For example, lighting justification is pretty easy. We're looking at all crashes, daytime versus nighttime, as opposed to looking for a specific crash type of severe injury, bicycle-related crash, or a specific type of pedestrian-related crash for systemic improvement. So how do you overcome those? As you drill down and become more specific, your sample size kind of disappears, and it's harder to find that trend.
So in the case of the Seminole tribe of Florida, they, with having such a small system, they didn't have a lot of crashes. So, from a very high level point of view, like, hey, that's good. You guys don't have a lot of crashes. However, they still have crashes and severe crashes at that point, and it's still just, it's too many. And so what we were able to do to justify the approach to identifying risk with a minimal amount of crash data was to supplement with what else is out there right now. What is the literature saying? What is other agencies doing, and what are the current reports saying would be the most appropriate in selecting countermeasures to address a potential concern. And so, yeah, as you pare down, get to the bottom of that crash tree, you might not have a lot of crashes, However, that's where this whole concept of risk comes back in. Even though you're looking at a smaller subset of crashes, and you're getting very specific crash types that you're focusing on, there are countermeasures that target specific crash types, and so it's definitely something to be aware of, and it can be challenging at times. But we're able to rely on the literature and what's out there to do some research to come to that meaningful conclusion.
And we've also expanded the number of years. The beginning of all that is a historical crash analysis. So a lot of times we start with 5 if we have, at a county or a state level, a district level, or something like that. But you can expand it to 10 or 15 to increase your sample size, and that can be challenging at times because a lot of times the crash forms have changed over the years, and so there's a little bit of transferring data to be consistent. But that can certainly increase your sample size, and you can. This is not the most desirable way, but you can try to find similarly functioning roadways with similar ADTs and similar crash patterns, and that's another consideration. It's something to supplement if you have to, I think. But bottom line, we were still able to the accuracy is certainly not as good as you get to that lower sample size, but we were still within a reasonable accuracy range after the Seminole Tribe analysis.
Sure. Yeah, just working with what you're given. I don't have anything else coming in the chat right now, but just send us some canned questions that are always good that I always ask. Or any lessons learned. Where you began your approach kind of in one direction and ended up doing it a completely different way. Some do's and don'ts. Something in your experience that you've learned where an agency that is looking to do the systemic approach definitely do this. Maybe something that it might seem like a good idea, but something not to do. Any sort of final words of wisdom that you guys may have in closing here.
The first time that Minnesota tackled the county road safety plans, it actually started off as a pilot project for one county, and it was the county included the city of Rochester, where the Mayo Clinic is, and so it's a decent-sized city, but ultimately, there was really good feedback from them, and then all of a sudden, it was a state-funded project, and so they said, okay, every county is going to get one of these plans. And so as we started into this process, we finished up phase 1, which was, I think, the first 10 or 12 or 15 counties, whatever it was in that first ATP. And then as we're going on to the second one, we're like, oh, well, maybe we should, keep our old records and start adding to it. And so creating this comprehensive database that, basically takes an inventory of the entire state was something of more of an afterthought once they were, halfway through the project already. And so it's data management is key, because there's going to be a lot of data. And being very upfront and thorough with how that database is going to be managed and who's going to be managing it is key in order to make it usable in the future and not just have it be shelved after the fact.
So this is not so much a lesson learned, but this is a potential next step. Looking forward, I think we talked about the identification of risk factors. We talked about those thresholds with which we use to identify whether a location qualifies as having a risk factor or not. Joe Santos has expressed some interest long-term in using some of those thresholds in policy discussions, and I think that's a really interesting discussion where we've entered into this territory now where we can get to performance-based design a lot better than we used to, and I think there are definitely discussions that are pretty interesting that stem from that we don't have to necessarily build a Cadillac to achieve the targeted safety performance, and that may be able to save agencies money. And so I think having this data-driven information could do that. It could help in that process if that were something you were interested in doing. And that is something I think we worked with Pennsylvania DOT along those lines, and one or two other clients to start to go down that territory. That's the other big lesson learned. We already sort of talked about it, but was to include the HSIP applications. I think when we first started, we did not. We had a deliverable that had site-specific locations, but we had not coordinated with the DOTs or whoever the overseer of those HSIP funds was, and developed a compliant application. And the idea to do that was based on our conversations with the locals and their discussions, their explanations of the struggles that they go through to put together a good, justifiable application. And so that was really us trying to listen to the feedback we've gotten, and I think that's been one of the bigger selling points, if you will, to this process is if you're an agency and you're in a state that's been able to have success using these projects from this process to get HSIP funding, chances are you're going to have better success, and you're going to bring in more dollars that are not free dollars, but certainly are viewed as, they're not part of your program, and you're supplementing it and making it better as a result. So that's it.
Great. Yeah, that's a great comment there at the end with the HSIP. It's the application of it. Otherwise, it's just sort of like a mental exercise and prioritization projects. If you have the application that comes along with it, then now you can do something with the data. So that's great. Let me take another look here. Yeah, there's nothing else coming in the chat. So I guess we can conclude our webinar here. I'll end the recording in a second, and we always stay on the line for a few minutes in case something else comes up. But wanted to say to you guys, thank you so much. I mean, this was a very interesting presentation, and you guys are obviously knowledgeable about this, and gave us a lot to think about.
Chad and Robert, this is Dennis. Just wanted to thank you guys very much. Also, this is great. Good discussion and a great presentation. Appreciate it.
Well, thank you. We appreciate that. That's big shout out to Peter. He was the one that reached out to set this up, and we really appreciate the opportunity because, as I mentioned at the beginning, we're really passionate about this, and we've seen some compelling results. So.
Yeah, it's evident by the way you handled the presentation and your questions. So. Very good.
Thank you.
Okay, well, with that, I will end the recording. Thank you, everyone, for attending.